Hello, my sweet and precious 7th graders. Thank you so much for joining me for these videos. I'm super delighted for this lesson number 24 because guys, today what we are going to be doing are reducing fractions. And guess what? You are going to reduce fractions from now until forever. So this is reducing fractions part 2. The part 1 I think was a couple videos ago. So if you haven't watched that, make sure you do. But part 2, we're going to talk about this. Use prime factorization to reduce this guy. 420, and guys, if you are in my class, which I know you are, you need to be writing these down, right? I'm showing you how I want you to make sure that your work looks like this, right? So when you're doing your homework, it needs to really look like this. So 420, this is example number 1 in lesson 24. So let's see your notes. 1050. Straight off the bat, guys, if you have a fraction that ends in zeros, make your life easier and lob those zeros off. Really, we're dividing by 10 on the top, but just lob those off to get rid of them. So another way of reducing these fractions, and I kind of talked about this in the last video, is prime factorization. Prime factorization, or in the last reducing fractions video. And prime factorization, we go over that in I think lesson 21 or 22, something like that. What we want to do are reduce down to our prime numbers. Remember, our prime numbers are 1, 2, 3, 5, 7, 8, 9, 10, 11, 13, right? Okay, so 42 can be reduced down. We can divide that by 2 and get 21, or we can do 7 and 6, right? 7 times 6 would give us 42. 6 can be 2 and 3, right? So 7 is prime, so I'm going to circle that. 2 is prime, 3 is prime, bam. What I'm saying back up here is 2 times 3 times 7. 2 times 3 times 7. Now on the bottom, I'm going to erase here just because I don't have enough room, but make sure that you're writing that down. 105. Well, we know 5 is divisible by 5, right? So if we do that, we get 5 and 21. I'm going to double check my math because one of my 6th graders caught me making a mistake. So, yeah, okay. Now I'm second guessing myself. 5 we know is prime, bam. This breaks down into 3 and 7. 3 and 7. So I'm gonna write these in order, 3 times 5 times 7. Guys, on the top and bottom, if I have something on the top of a fraction, something on the bottom of a fraction, I can lob them off. This 3, get rid of it, bye-bye. This 7, done. What do I have left? 2 and 5. 2 and 5. So I've just reduced this fraction down to 2/5. All right, let's talk about example number 2. My desk raises and lowers and I had it up a little too high. So example number 2, we have 9 over 16 times 2 over 3. Well, 9 can be broken down into 3 times 3, right? 16 can be broken down to, and this is a good one to remember, 4 times 4, but that's not prime. 2 times 2 times 2 times 2. So that 16 is 1, 2, 3, 4, 2 to the 4th power, right? Or just, we're going to say 2 times 2 times 2 times 2. All right, guys, so I'm going to rewrite this, right? At the top now, I have this times this times this. So this is going to be 3 times 3 times 2. You don't have to specifically put it in order if you don't want to, that's fine. On the bottom, I have 2 times 2 times 2 times 2 times 3, okay? This 3 and this 2 lob off, this 2 and this 3 lob off. All right, on the top, we have 3 left, but on the bottom, we have 2 times 2, which is 4, times 2, which is 8. So 9/16 times 2/3 reduces down to 3/8, okay? What you could have done is 9 times 2 gives you 18, 16 times 3, and do it that way. That's totally fine too. I'm just trying to show you different methods of making your life easier, guys. I say this all the time in my class. I'm lazy. I want to find the easiest way to do something, and of course I'm going to share it with you, my beloved students. All right, so let's look at example number 3. We have 8 over 9 times 3, 10 times 5, 4. Guys, you could sit here and multiply straight across the top, multiply straight across the bottom, you're going to be here all day, okay? You're going to be here all day. But what we can do is we know that this breaks down into 2 times 5. Well, golly gee, we have a 5 up here. And guys, this only works because it's multiplication. If this were addition subtraction, we would have to find a common denominator. You cannot cross cancel. That's what this is called, is factoring by primes and cross canceling. So we know 10 is really 2 times 5 in hiding. We've got a 5 down here, 5 out here, bam, that's a 1, okay? It's not a 0. When you cross everything off, it's not a 0, it's a 1. Over here, this 4, well, 8 breaks down into 2 times 4, doesn't it? So let's, bam, we got a 1 there. 3 breaks down, can't break that down, but 9 is 3 times 3. So now I have a 3 upstairs and a 3 downstairs. Let's get rid of those. All right, so now we got to collect all of our information. Upstairs, we have 2 times 1, which is just 2, right? Downstairs, we have 3 times 2, which is 6 times 1, so 6. Oh, that means I didn't do something. Yaha! Yaha! Look upstairs. See that 2 there? There's a 2 there. Bam, bam, gone. It's a 1, 1, right? It's never 0 on top. So upstairs we have 1 times 1 times 1. That's all just 1. I don't know why my pens are bleeding like that. That's very annoying. And downstairs we have 3 times, that's it, 1/3. See, you know that you did a mistake when you saw that I had 2/6 and I looked at that and I was like, oh, I forgot something. So if you can reduce it down again, you probably forgot something up here, but in this case, they're both even, so you would just cut them in half, right? Good, so that's example 3. Let's talk about example 4. Example 4, this is 27 over 32 times 20 over 63. Blah. Big numbers. You could sit here and multiply them across, straight across the top, straight across the bottom. You could, but more power to you. What we know 27 can be is 9 times 3, right? So let's just break that down. Over here, we know that this can be 9 times 7, right? Well, yeah, we can get rid of some 9s. Bam, bam. Good deal. This guy can be, let's say, 2 times 16, right? Well, this can be 2 times 10, right? Well, there's that. Okay, oops, I gotta cross these guys out too. So that means right now upstairs, and so sometimes you have to rewrite it if you're cross canceling, right? I have 3 times 10, but instead of 10, I'm gonna write down 2 times 5, right? And then down here I have 16 times 7, so I'm gonna put a 7 here, but instead of 16, I'm gonna do, let's just do some prime factorization. We know it's 4 and 4, which is 2 and 2, 2 and 2. So it's 2 times 2 times 2 times 2 is 16. And then I got that 7, right? Oh, so there's definitely things we could still cancel out. Those 2 guys right there. All right, so on the top I have 3 and 5, which gives me 15, because remember I'm multiplying. And then I have 2 times 2, which is 4, times 2, which is 8, times 7, which is 56. 56. So that's as reduced as it's going to get. We got down to those prime numbers. It's as reduced it's going to get. All right, so practice is on page 136. Go ahead and get started on that. Pause the video, give those an attempt, and then come on back. A is 48 divided by 144. Okay, 48, that's 24 and 2, right? And then this is 4 and 6. This is 2 and 2. Circle, circle. I forgot to circle this guy. 2 and 3, right? 2 times 2 is 4, times 2 is 8, times that is 24, times 2 is 48. So we've got 1, 2, 3, 4. So 2 times 2 times 2 times 2 times 3 over, now 144. You guys, this prime factorization is, I want to see all of this on your paper, right? Do you see everything that I'm writing down? You gotta be writing things down to get those problems. This is 12 times 12, right? We know that's 3 times 4, 3 times 4. Those 3s, those are prime, 4s are not. All right, so we have 1, 2, 3, 4, 4 2s. 1, 2, 3, 4, and then 2 3s. Bam. All right, I'm gonna erase this guy. Good, so up there I have these 4 can go away, so can these 4, right? And then this 3 and this 3. What do I have left up top? I've crossed everything out. If you said 0, you are absolutely incorrect. It is a 1. So this all reduces down to 1/3. No, that was a fancy 3. Fancy. 1/3. All right, so for B. 90 over 324. I have to pause this. All right, so let's do this guy, 90 and 324. Let's do some, I can't lob off on these zeros. Nah. So we're gonna have to do some prime factorization. We know this is 9 and this is 10, right? This is 3, 3, this is 2, 5. So we're gonna come up here. We're gonna write down 2 times 3 times 3 times 5. I like to put it in order, you don't have to, but habits are hard to kick. All right, 324. 324. Well, I know that it can at least be divided by 2, right? So I'm gonna put a 2 here. Half of 300 is 150. Half of 24 is 12, which means it's 162. 162. And that can be circled. Now, I know that this can be divided into 2. Half of 16 is 8, and half of 2 is 1, right? So that's gonna be 81, which we know is 9 and 9. Oh, forgot to circle that. We know this is 3 and 3, 3 and 3. So I got 2 times 2 times 3 times 3 times 3 times 3. Okay. All right, so we come back up here, lob that off. Lob that off, lob that off. Good. Upstairs we have just 5 remaining, so 5. Downstairs we have 2. Well, we have 3 times 3, which is 9, times 2, which is 18. So for B, your answer should be 5/18. All right, so that was C. Find the greatest common factor. Greatest common factor of 90 and 3. Oh, I shouldn't have erased that. All right, let's talk about this greatest common factor. How to find those guys. We could do. Let's do this. Let's go back and do those prime factorization again. 90 was 9 and 10, which means it was 2 times 3 times 3 times 5, right? And then this one was 324 was 4 and 81, which means that this is 2 times 2, and then 81 is 9 and 9, so that's 4 3s. All right, why are we doing it this way? Well, so this is, I've got it in fraction form here just so that we can organize ourselves. You don't absolutely have to do this. The way to find our greatest common factor is to look at these guys and think, okay, so if we did, so there's 2 2s here, or there's, this is getting, all right, so let's do it like this. We've got a 2 here and 2 2s there, okay? That means the most that we have are 2s, so we gotta do 2 times 2, okay? Now let's look at those 3s. We have 2 3s here, we have 4 3s here. That means we gotta do 4 3s, because you choose whichever the most is, okay? We have a 5 here, so we have to do a 5. So if we multiply all of this information together, we would get our greatest common factor. So I just did least common. Actually, if you multiply all this together, you get your least common multiples. Sometimes this happens, guys. I'm so sorry. So 4, this is 9, that's 81, right? Times 5. So 4 times 81 times 5 is, least common multiple is 1620. Least common multiple. Guys, this will actually come up in a different lesson, so I'm so sorry about that. Greatest common factor. I don't know where my brain was. I'm like, why are they introducing this? But sometimes that happens, and I don't know how to rewind, so lucky you. All right, 90 goes like this. Greatest common factor, factoring. We do 90, start with your easiest. 1 times 90, right? 2 times 45. 3 times 30. Not 4, right? But 5 is 18. After 5 comes 6. 6 does not go into it. I'm sorry, 6 does. I always skip that one. 6 times 15. After 9 is after 6 is 7, no. 8, no. 9, yes. 9 times 10. After 9 comes 10. 10's already on the board. We're good. 324. 1 times 324. 2 times, what was that again? 162. Yeah, okay. I literally, parents, if you're watching this is literally how I teach in the classroom. Like, oh, wait, what? So nobody's perfect. Okay, so divided by 3. Oh, remember our trick for dividing? I wasn't sure if 3 went into this, but 4 plus 2 is 6, 7, 8, 9. So not only does 3 go into it, but 9 does too. 3 goes into it 108 times. 324 divided by 4 is 81. 3, for finding these greatest common factors, guys, I'm totally okay if you want to use a calculator. For the most part, I'll talk to you guys individually about this, but okay, after 4 is 5, 5 does not go into it, so we've got to do 6, 6 times 54. After 6 comes 7, 324 divided by 7. Nope, 324 divided by 8 is, oh no, 324, we know 9, so 9 times 36, right? Not 10, not 11, but 12, 324 divided by 12 is 27. We're getting there, guys. Not 13, not 14, not 15. Let's see. Not 16. 18. Oh, yeah, 18 times 18. I'm sitting here. I just did perfect squares with a different student earlier. So 18 times 18, after 18, but now we're starting to repeat itself, right? So finding greatest common factor for this guy is 90, 45, 30. I don't see any of those. 18, bam, 18, 18. They also have in common, it looks like 9, 9, 6, 6, 3, 2, 1, 3, 2, 1, 3, 2, 1, right? So the greatest common factor is 18, all right? Any questions? Let me know, which means you could divide the top and bottom by 18 if you wanted to. All right, so any questions, let me know. Otherwise, let's see what we've got. Oh, we've got a couple more. Sorry, not over yet. D, 5 over 8 times 3 over 10. All right, so we know that 10 can be rewritten as 2 times 5, right? And yes, we can lob this guy off and this guy off. Upstairs, I have 3. Downstairs, I have 8 times 2. I can't get rid of any of those, right? Because 3 does not go into 8 and 2 does not go into 3. So 8 times 2 is 16. So that's your answer. 8 over 15 times 5 over 12 times 9 over 10. Guys, you can multiply straight across top, straight across bottom if you wanted to, but don't waste your time. Okay, so we know that this can be 3 times 3. We know this can be 2 times 4. And of course, we know 4 breaks down again, but that's fine. 5 is perfect. So, not perfect, prime. 3 times 5, right? We know that this is 4 times 3. Now, guys, I could have chosen 6 times 2, but I have a 3 and a 4 up here, so I deliberately did not. And we know this is 2 times 5, right? So let's see if we can lob some of these things off. I see a 2 and a 4. 4, 2, right? Then that 5, I can get rid of that. 5. I see a 3 and a 3. 3 and a 3. Beautiful. Upstairs, I've lobbed everything off, which means it's a 1. Downstairs, the only thing I have remaining is 5. So your answer should be 1/5. So however you want to do that, that's fine. If you want to multiply all the way across the bottom, you can. Just keep in mind that that's not always the best method. All right, so F. All right, so 8 can be broken down into 4 times 2, right? 6 can be broken down into 2 times 3. 5 can't be broken down because it's prime. This, how about I do 4 times 4, right? Because I've got a 4 up there, but I also have those 2 2s. Do you see that? So I'm going to change one of these to 2 times 2, okay? 7 is prime, 3 is prime. So now we can start lobbing off. This and this, bam, gone. This 4 and this 4, gone. This 2, gone. This 2, gone. So upstairs I have 5, downstairs I have 7. So 5 sevenths. 5 sevenths. All right, factor and reduce before multiplying. 36 over 45 times 25 over 24. All right, so for this guy, actually, I'm going to move that down a little bit. Bear with me. 36 over 45 times 25 over 24. All right, straight off the bat, 25 can be reduced down to 5 times 5, right? 36 can be reduced down to 6 times 6. This can be 5 times 9, right? 24 can be 6 times 4. All right, let's see if we can lob some stuff off just to start. We can get rid of that 6, get rid of that 6, get rid of this 5, get rid of this 5. Okay, upstairs we have 6 times 5. I'm just going to rewrite this, 6 times 5, just so that you can see it without it getting too confusing. Downstairs we have 9 times 4. All right, so what I do know is I can rewrite this as 3 times 3, and this can be 2 times 3, right? That means this 3 and this 3 lob off, and we have upstairs 2 and 5, which gives us 10, and downstairs we have 3 and 4, which gives us 12. Oh, see, I missed one, because look at this. That 4, let me back up. This is why I rewrite it, because if you're doing a whole bunch of these, it can be a big pain. This 4 can be rewritten as 2 times 2, right? So now I can get rid of this 2 and this 2, which means upstairs I have 5 and downstairs I have 3 and 2 left, which is 6. 3 and 2. If you need to do it a couple different ways, that's totally fine. All I want to know is that you know how to reduce fractions, because you're going to have to do those from now until forever. All right, guys, if you have any questions, let me know. Otherwise, great work, and I will see you in class.